In this video, I will discuss different raster interpolation methods, as well as a couple of different methods of terrain analysis. Interpolation predicts unknown values for each cell based on a number of sample data points. This is often used to create elevation and rainfall maps based on values at points where sensors are located or the value is known. All interpolation techniques are based on spatial autocorrelation, which is defined by the first law of geography. The first law of geography states that all things are related, but near things are more related than far things. In other words, the value of one location is more likely to be similar to or correlated with a point that's next to it than it is to one that is further away. An easy way to think about this is with elevation. In general, the elevation of one point is likely to be closer to another point that is 1 foot away than it is compared to a point that isn't 1 mile away. Unless you have a cliff. There's always that potential possibility. Spatial autocorrelation is a measurement of the statistical relationship between the measured points. I'm going to go over the two most common interpolation methods, including inverse distance weighted, or IDW, and kriging. The most popular interpolation method and simplest is IDW, which is the inverse distance weighted tool, which estimates cell values based on the weighted values of the neighboring cells. It's a form of focal statistics. The only difference is that it includes weighted values, so that the closer the neighborhood cell is to the target cell, the more weight or influence it has within the calculation. It's calculated by using the inverse values of the distance. That way, the further away the point is, or larger the number is in the denominator, the smaller impact it will have on the final result. For example, in the slide, the IDW is being calculated by using its 3 closest neighbors. The value of 12 is the closest, so it will have the most influence, followed by the 2 different values of 10. Although IDW is based on spatial autocorrelation, it does not actually factor that into the calculation. That's where kriging comes in. Kriging is more advanced than IDW and calculates the cell values based on the z-values of the point spread across the area. It's an advanced geostatistical procedure that generates a data set that is estimated from points scattered throughout an area, which include the z-cells, which represent the variation among the data in order to mathematically take the spatial autocorrelation into account. Calculating it is quite complicated and you will not know how to do that, so I am not even going to include that formula in the slide. I just want you to know that kriging is more of a analytical statistical tool and IDW is more of a quick and dirty creating a surface model. Lastly, I'm just going to quickly go over a few different terrain analysis tools, some of which you used last week in the lab. So terrain analysis allows you to quantify and visualize terrain based on a digital elevation model dataset, which you couldn't see by just looking at the DEM. So the DEM is in the top right corner in the image. The most popular analysis tool to create a raster dataset with terrain analysis is the slope angle. And there's also the aspect, which is a steepest downslope direction, hillshade, which shows the shade of relief and makes the image look more three-dimensional, and that takes into account the slope, aspect, and sun direction. And then lastly, it can be used to create a vector data set of contour lines. And if you remember from a few weeks ago, contour lines are lines of equal value. You don't need to know how to calculate these either. I just want you to be familiar with the names and somewhat of the processes. That way you are able to implement them in your final project. So that's all for today. Have a great rest of your week.